So we have a couple more equations here. This first one, we have everything very similar where we need to set it equal to 0 because of that m squared. So I get 8m squared plus 20m minus 12. And this is something like we talked about before, you can just do in your head, move that 12 over. Even the stuff on the other page where I had to move 3 terms, that's fine. You have to be careful though, because you're doing so much at the same time that you might want to show that. So from here, looking at this, I have a GCF of 4. So I'm going to take out a 4, making this trinomial much easier to work with. So minus 3. Maybe I'll bracket this off because I know what's coming in the next step. So now we need to rainbow. So we are looking for factors of -6 that add up to 5. Be really careful because that 2 and 3 pops right out. But 2 times 3 is not -6. And -2 times -3 is also not -6. And if I do a 2 and a -3, it is -6, but it doesn't add up to 5. Okay, so we have to use for this +6, -1. 6, I would say, is the most error-prone factoring because the 2 and the 3 and the 1 and the 6 seem to do kind of similar things in terms of adding and multiplying, but it's not perfect unless you do it the right way. So this is 6m minus 1m minus 3. So I have 4, group. So I have 4 times m plus 3 times 2m minus 1. Now I can tell that 4 is not going to give me an answer, okay? And this is because we're solving. If I was just factoring, that 4 can't go away because then I would change the expression. But if I write 4 equals 0 here, right, that goes away. 4 can't equal 0. And from the second factor, I get -3, and the third factor, I get 1/2. Now, letter G is interesting because you can say, oop, I already got it factored, right? But the zero product law, the reason we're factoring, only works when the equation equals 0. So it seems like a lot of extra work, but we actually have to multiply this out so we can set it equal to 0, and then we have to refactor what we have at that point. So this is 2x squared minus 3x equals -4x squared plus 20x. When I'm making a decision about moving my terms, I want to keep my x squared positive, so I'm going to move over the 4x squared and the 20x, right, making this positive 4x squared. So we end up with 6x squared minus 23x equals 0. So here I just have a GCF. I take out an x, and I have 6x minus 23 left. So I get x equals 0 from this x factor, this monomial factor, and then from the other one I'm going to get 23 over 6. So I haven't been writing them in set notation because I haven't really had, or roster notation because I haven't really had room. But just as a reminder, it's nice to write it that way. I have room here, so I'm going to write that one that way. So exercise 3 is going to kind of lead us towards what we're going to talk about in the next lesson, but it also is going to lead us to exercise 4. So it says, the next lesson involves working with the shapes or graphs of algebraic functions. For the graph of any function, what is always true about the coordinates of the point where the graph crosses the x-axis? So if I draw any graph, and I'm asking, most graphs, unless they're horizontal lines or, certain types of functions, do at some point cross the x-axis. So let's say a graph crosses the x-axis here, and here, and here, okay? So here, and here, and here. So what we're saying, what do those 3 points have in common? And we did kind of talk about this in Unit 1. We're kind of focusing in again. So the thing that's true about each of those points or what they have in common, they're all going to have different x values, but every single one of these points has the same y value, and that same y value is always 0. So you can write the y is always 0. Okay? So when I talk about my x-intercepts, right, which also can be called zeros, shocker, right, or roots, basically I'm just saying the y value equals 0. So what that means in an equation, here we have, it says based on your answer to the previous question, or let's cross out that word 2 because it shouldn't be there. Algebraically find the x-intercepts for each function given below. So we know we could graph it on our calculator, but we're going to use algebra, which means we don't look at the graph, right? We just solve things. So if the y is always 0, that means that I can just plug in 0 for the y. So whenever I'm finding the x-intercepts, it creates the equation 0 plugged in for the y equals the equation. So that's just based on this point, right? 0 is the y, so I'm plugging in 0 for the y value. Now this one I can just add 10, right? This is linear, right? So I don't have to factor it. I know it might feel tempting to factor it, but I don't need to factor it, right? Because we don't have an x squared or an x, x squared and an x. So here I get x equals 2. And if I graphed y equals 5x minus 10 on my calculator to look at it, I would see that this crosses the x-axis at the point 2, 0. So looking at how this plays out in the rest of the equations, so we're finding x-intercepts. Just a side note, x-intercepts describe the x-axis. The word zeros describes the fact that I'm plugging in 0 for the y value. And the word roots, if you think of a graph as a plant, I guess is a way you could think of it. If this red line here was a plant, basically roots are where things go in the ground, where they're anchored, like anchored to the x-axis, your roots, okay? And so that's where that word comes from. So we're going to plug in 0 for y to find the x-intercepts. Now this equation is quadratic, right? This one was not, right? That's linear. This is quadratic, or x squared. So this one I do want to use my factoring. And this is difference of perfect squares. So the two spots this graph crosses the x-axis are 1/2 and -1/2. Moving down the page, we have 2 more to look at. So finding x-intercepts here, set the equation equal to 0. For this one, right, we should do rainbow and grouping, but I'm going to show you once in this video how you could figure these out just straight to the factors. So remember, this is new and optional. So I can think about this, and this one is easier to think about than some other ones. So if I have to get 3x squared, that's pretty easy because 3 is prime. So one of them has to be a 3x and the other one has to be an x. So now I need to pick numbers that multiply to -10 to go here and here, and I also have to put them down in a way so that with this 3x, they're going to make a 13. So thinking about my different options, if I try a 5 here and a +2 here, right, I get that those two multiply to -10. And if I did these two, right, those two distributions, I get -15x plus 2x. So that's actually wrong. But if I made this +5, and I need a baby eraser, so just give me a second. So basically I erased that. I had to pause the video because I was having some issues with freezing. And I make this a -2, then that gives me my +15 here and my -2, which add up to +13. So you can always do what we've done all the other times, but I just want to point out there is a way that you could figure these out with guess and check. So here I have a 2/3. Here I have a -5, and those are my 2 answers. So if that confused you, please realize we did a bunch of those in the beginning of the lesson. Basically, you would just solve it your normal way, right, where you would factors of -30 that add up to 13, and just really quickly, if I erase all this, those factors of -30 that add up to 13 are going to be, I can't erase and think at the same time. Those are going to be 15 and -2. So for some reason my eraser is not functioning properly. Let me just try one more time. No, not gonna work for me. Okay, so I'm just gonna cross this out. So that's gonna be positive 15, negative 2, and group. And here we end up with x plus 5, 3x minus 2, which is going to give us the same exact answers of negative 5 and positive 2/3 as when I did the guess and check method. So moving on to our last one, right? X-intercept, set the equation equal to 0. Here it's a GCF for a factor. So from this 5x, I'm going to get an answer of 0, and from this x minus 2, I'm going to get an answer of positive 2. So we'll be looking more at graphs next lesson, but that's basically the idea that another way we can use we utilize solving quadratics and ultimately factoring is when we're finding zeros of quadratic equations.